أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Today we'll be talking about Qur'an and neuroscience, executive functions, decision making and errors. Before I begin, I'd like to share some ayat of the Qur'an I'm currently learning. May inshallah make it easy for us to understand His word, His book, and propagate the faith to those known and unknown. Ameen. So I'm going to start with chapter 64. Surah At-Taghabun. At-Taghabun means mutual loss and gain. And I will be reciting from ayat 11 down to 14. أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. ما أصاب من مصيبة إلا بإذن الله ومن يؤمن بالله يهدي قلبه والله بكل شيء عليم وأطيعوا الله وأطيعوا الرسول فإن توليتم فإنما على رسولنا البلاغ المبين الله لا إله إلا هو وعلى الله فليتوكل المؤمنون يا أيها الذين آمنوا إن من أزواجكم وأولادكم عدوا لكم فاحذر فاحذروهم وإن تعفوا وتصفحوا وتغفروا فإن الله غفور رحيم. This is in English approximately as no kind of calamity can occur except by the leave of Allah. And if anyone believes in Allah, Allah guides his heart aright, for Allah knows all things. So obey Allah and obey His Messenger. But if you turn back, the duty of our Messenger is but to proclaim the message clearly and openly, so without error. Allah, there is no God but He, and on Allah therefore let the believers put their trust. O you who believe, truly among your wives and your children are some that are enemies to yourselves, so be aware of them. But if you forgive and overlook and cover up their faults, verily Allah is oft forgiving, oft merciful. Next, I'll be touching on Surah Al-Ankabut, which means a female spider. And I actually came across the recitation of a prisoner from Guantanamo Bay. I believe he was Moroccan or Algerian from Belgium, and he was arrested again 10 years ago. So his recitation really hit me, and I took it upon myself to learn this surah as time goes on. So far, I've only managed to learn 2 ayat with everything going on. So, inshallah, we proceed. Bismillah ar-Rahman ar-Rahim. Alif Lam Mim. حسب الناس أن يتركوا أن يقولوا آمنا وهم لا يفتنون ولقد فتنا الذين من قبلهم فليعلمن الله الذين صدقوا ولا يعلمن الكاذبين أم حسب الذين يعملون السيئات أن يسبقونا ساء ما يحكمون. So this approximates in English as Alif Lam Mim. Do men think that they will be left alone on saying we believe and that they would not be tested? We did test those before them, and Allah will certainly know those who are true from those who are false. Do those who practice evil think they will get the better of us? Evil is their judgment. So, decision making, as I see it here, is the evil ones will always have the foundations based within evil. Evil could be black magic, it would be treachery, gluttony, envy, greed, violation of one's dignity, human rights, manipulation of laws, manipulation of many aspects that they will ultimately utilize to achieve their own end goals. And there's a number of those end goals. For example, we've seen recently with how there's been protests in England, in the city of Manchester, and all of that is a distraction from the coin clipping child abusers, people who like to proclaim that they are beacons and bastions of civility and peace, but in reality, they have violated the most innocent thing that ever exists, which is one's consciousness at a young age. Anyway, so that's one group of recitations. Another one I would like to share with everyone is Surah Al Anfal. This is quite a potent ayah. Al Anfal means spoils of war. So, war booty, things that are left over. So, this is from ayah 36 to 37. And this one really hit me recently as I was reading into the Battle of Uhud and its history. Bismillah ar-Rahman ar-Rahim. إن الذين كفروا ينفقون أموالهم ليصدوا عن سبيل الله فسينفقونها ثم تكون عليهم حسرة ثم يغلبون والذين كفروا إلى جهنم يحشرون ليميز الله الخبيث من الطيب ويجعل ويجعل الخبيث بعضه على بعض فيركمه جميعا فيجعله في جهنم أولئك هم الخاسرون. So this approximates in English as the unbelievers spend their wealth to hinder men from the path of Allah, and so will they continue to spend. But in the end, they will only have regrets and sighs. At length, they will be overcome, and the unbelievers will be gathered together to hell in order that Allah may separate the impure from the pure. Put the impure one on another, heap them together, and cast them into hell. They will be the ones to have lost. So some say, so another translation I read by Mustafa al-Khattab is evil from good. This is impure from pure. So that's quite fascinating. I mean, khabith is impure in Arabic as far as my Arabic knowledge stretches. Last but definitely not least is another ayah in conjunction with this that I came across when looking at Ibn Kathir's tafsir is Surah Al Imran, ayah 142. أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم أم حسبتم أن تدخلوا الجنة ولما يعلم الله الذين جهدوا منكم ويعلم الصابرين. Did you think that you would enter heaven without Allah testing those of you who fought hard in His cause and remained steadfast? So you can see there Surah Al-Ankabut, so Surah At-Taghabun and Al-Kambuth were in a sense very general, and Surah Al-Anfal is hyper focused on the incident of Battle of Uhud, and then this is another ayah that culminates what we were discussing. Right, so now we're going to move forward from here and look at the Wisconsin card sorting test. Something that we've been exploring for the past weeks. Quite frankly, it's a area and topic that I'm researching in. And what I like to do is, of course, share some papers, share insights, notes, and break down some complicated stuff here. So let's begin with O'Reilly's work here. I know there's another author, but I just find his name easier to understand, from 2001, 2001 or 2002, whatever. Right, abstract. The prefrontal cortex is widely believed to play an important role in facilitating people's ability to switch performance between different tasks. We present a biologically based computational model of the prefrontal cortex that explains its role in task switching in terms of greater flexibility conferred by activation-based working memory representations in PFC as compared with more slowly adapting weight-based memory mechanisms. So what's being stated here is that they have a biologically based computational mechanism whereby they are looking at how the mind, i.e., the prefrontal cortex, is able to switch tasks and the measurement of flexibility here, and how all of this flexibility is conferred by activation based working memory representations. What does that mean? So there's various types of memories we have in terms of in theory. Okay, this is not set in stone, but these are the most agreed upon, pardon me, widely agreed upon and most workable models. So working memory, one of them states that when you are engaged in a task, the memory you have, whether it's linguistics or visual or auditory, all of that is working simultaneously in tandem whilst you're working on a task. So just going back to this paper here, doing this exercise, picking the right word, picking the right shape, picking the right color, right, wrong are these options. And so what's happening is working memory is being used here. Your memory of color, memory of shapes, your memory of words, your memory of grammar, your memory of capital letters, small letters, the hand that you can see, so on and so forth. So all of this data is being processed within the working memory mechanism. So as compared with more slowly adapting weight-based memory mechanisms. So now they're looking between the activation-based working memory representations in the prefrontal cortex, is usually fairly quick. By quick, I mean it's swift. Compared to more slowly adapting weight-based memory mechanisms. So weight-based memory meaning that each representation, each unit on the grid. So imagine a grid, and each grid has a shaded square, different shaded squares. One's dark, let's say black. One's less than black, let's say light gray, and one's white. So in all three shades, each carry a weight which can be mathematically calculated, and it can correspond to activation and representation. So that's what they're looking at. That's what they are looking at in this paper. Okay. So biologically based computational model of PFC. You have conferred, let me just remind myself what that means. Grant, benefit, given the right, have discussions, exchange. The minister may have exceeded the powers conferred on him by Parliament. The officials were conferring with allies. Bestow upon, grant to, award to, decorate, honor with. Okay. Explaining how activation based working memory working memory representations in PFC. In PFC grant granted by task switching, task switching, and greater flexibility. Right. So we got this here. Specifically, we show that PFC representations can be rapidly updated when a task switches via dynamic gating mechanism based on temporal differences, reward prediction learning mechanism. So they are showing that prefrontal cortex representations can be rapidly updated when a task switches. So when a task goes from choosing a shape to choosing a color to choosing a text via dynamic gating mechanism based on a temporal differences, so differences in time, reward prediction that predicts the reward, learning mechanism. Very interesting. Okay. Right. Okay. So shows PFC representations can be rapidly updated when a task when a task switches via a dynamic gated gating sorry gating mechanism based on a temporal differences reward prediction learning mechanism. Okay. Unlike prior models of this type, the present model develops all of its internal representations via learning mechanisms as shaped by the demands of continuous periodic task switching. So previous models are different than this one. And the reason this one's different is because it develops all of its internal representations through learning mechanisms as shaped by the demands of continuous periodic task switching. So learning by continuous, okay, periodic task switching, periodic task switching and pretext is this model, okay, develops all of its internal representations. Okay. This advance opens up a new domain of research into the interaction between working memory task demands and the representations that develop to meet them. So advance months into interaction, into the interaction between working memory, task demands, and representations are developed to meet them. And representations that develop to meet them. Okay. Results on a version of the Wisconsin card sorting task are presented for the full model. Results on a version of the Wisconsin content are presented for the full model. A number of comparison networks that test the importance of various model features. So comparison networks. Interesting how they really go a bit deeper than expected. Comparison networks that test the importance of various model features. Okay, that test various model features. Okay. Furthermore, we show that a lesion model, so this is a hypothetical model where lesions in the brain produces more error, as we know, and difficulty in decision making, as we know from the literature. Furthermore, we show that a lesioned model produces preservative errors like those seen in front of patients. So, furthermore, we show a usage of a lesioned model which produces preservative errors, preservative errors. I can never say that word for some reason. Subhanallah. Like those in frontal patients. So there's an element of clinical neuroscience here, slightly, not entirely. Okay. So introduction. Now I've done this paper before. I still think it's relevant at the end of the day. We've probably all had the experience of trying to pull a door that should be pushed, or vice versa. When it doesn't work, you have to switch your approach and try the opposite maneuver. Sometimes, however, you might catch yourself failing to switch and retrying the incorrect maneuver again. This kind of preservation This kind of perseveration behavior is a hallmark of patients with PFC damage. The classic task for demonstrating the involvement of the PFC in task switching is the Wisconsin card sorting task. Grantberg, Heaton, Milner. Though the literature on this remains somewhat controversial, so I'm intrigued to know these papers. In fact, let's check them out right now. I'm gonna open a new window here. Mary Ann Mountain and William G. Snow. We reviewed the studies of WCST in which the test was administered to subjects with and without evidence of focal frontal lobe dysfunction. Let me actually share this. This could be of some benefit. What's going on? Where's it gone? Okay. This review indicated that few studies have investigated differential performances of normals and those with frontal dysfunction. The evidence that frontal patients perform more poorly than non-frontal patients is weak. There is insubstantial evidence to conclude that WCSD is a measure of dorsolateral frontal dysfunction. Right, so this is zeroing in, focusing on the dorsolateral frontal lobe. So that is the latter bottom part of the frontal lobe. Here we go. So lateral bottom, well, it's not bottom, sorry. This is the upper portion. This one here. Okay, dorsolateral. Dorsolateral prefrontal is a critical region of the human brain located in the middle of the gyrus, often described as the brain's central executive, primarily responsible for higher level cognitive processes and executive functions. Key function: the DLFC acts as a hub for complex mental activities, including working memory, holding and manipulating information in the mind, such as keeping a phone number online while dialing it. Executive control: planning, organizing sequences of actions, and cognitive flexibility, shifting between rules or tasks. Decision making: involved in rational, moral, and risky decision making, as well as suppressing selfish impulses to maintain social norms. Top down regulation: modulating attention to filter out irrelevant information and regulating emotional responses through connections with deeper brain structures like the amygdala. Language and pragmatics: complex managing complex sentences managing complex sentence processing, maintaining discourse coherence, and interpreting non-literal meanings like irony or sarcasm. Because of its high-level control, dysfunction in the DLPFC is linked to several neuropsychiatric conditions. Depression, characterized by hyperactivity in the left dorsolateral prefrontal cortex, which is often targeted by repetitive transcranial magnetic stimulations to alleviate symptoms. Schizophrenia, associated with hypofrontality, reduced activity, and structural changes in layer 3 of pyramidal cells, leading to working memory deficits. ADHD involves atypical dorsolateral prefrontal cortex activation, contributing to deficits in impulse control and organization. Dorsolateral syndrome: damage to this area can result in an apathetic syndrome, causing a loss of initiative, attention, and free will. Development anatomy: the DLFC PFC is one of the last brain regions to fully mature, development continuing into mid-20s, early 30s. This late maturation is linked to the emergence of advanced strategic thinking, impulse control during adulthood. Would you like to learn more about our... No, thank you. So, I'm going to state who discovered this and what method were utilized and where. Broadman provided the first topographical description of the regions now considered the DLPFC using cytoarchitectural criteria studying the structure and arrangement. Broadman areas, 9 and 46, as distinct granular regions of the primate frontal lobe. Early functional insight. Carlisle Jacobson, Yale, was the first to uncover DLPFC's role in the generation of thought. He used the term prefrontal especially to distinguish these granular areas from motor regions. Carlisle Jacobson. Okay. Defining working memory. Patricia Goldwyn Rakic is always those. Every single Stein. Patricia Goldwyn Rakic is widely credited with establishing the DLPFC as a central executive working memory. Her work at Yale fundamentally shifted understanding of how brain keeps information online. Human systematic study in the 60s, Brenda Milner, working at the Montreal Neurological Institute, performed the first systematic studies of how focal DLPFC damage affected human cognition. Okay. Utilized methods. Three primary scientific methods were used to isolate DLPFC's function. Number one is lesion studies. Researchers observe behavioral changes in non-human primates and human patients, like Wilder Penfield, who had surgical removals. Yeah, I'm familiar with Penfield's work. Single unit recording is, of course, classic. Scientists record electrical to the individual neurons, monkeys. They reveal delay period when neurons fired continuously told information. Yeah. So there is a where did I read it? think it was Redditch's work where I read something like this. Not collateral. Where are we? Here we go. I'm pretty sure I read it here. 139 43 to 139 141 Sneak Yadin behavior inhibition basal ganglion. Nope. This is not the one. 43. I think this one. Chapter 15, 43. 15, 43. Yes, Joaquin Foster's work as well definitely points this out. Let's quickly pull out his book. Here that I conveniently have to my side. Okay. Two. Yeah, it's talking about the same thing as well. Interesting. Yeah. Hmm. So if I go to here, Foster, Damasio, Knock, not Damasio, Foster. Okay, these guys, Somerville. Okay. Okay, neuropsychological testing tools like WCST are adapted to by Milner to specifically test shifting and cognitive flexibility, which were found to be severely impaired by dorsolateral prefrontal cortex. Okay, she might still need this one. Interesting. Berlin, Montreal. No, I do not want to know specifics. The clinical utility of the test as a measure of frontal lobe dysfunction is not supported, nor is the use of the test as a marker of frontal dysfunction for research purposes. Okay, right. Let's close this and minimize this one. Go back here. Rieten and Wolfson, Stoss and colleagues. Let's look at Rieten and Wolfson. Shut this off. Mm, things. Mm, yes. Okay, so this is interesting. 1994 publication by Ralph and Deborah, Selective Critical Review of Neuropsychological Deficits in the Frontal Lobe, published in the Neuropsychological Review, challenges the traditional widespread belief that tests like the WCST are exclusively or specifically measures of frontal lobe dysfunction. Key points related to their view, critique of frontal specificity. Retan and Wolfson argued that while the WCST is sensitive to brain damage, it's not sufficiently specific to frontal lobe lesions, as deficits can appear with other more diffuse or non-frontal pathologies. Weak evidence for localization. The review highlighted that the bewildering array of deficits frequently attributed from evidence questioning the strict localization of functions like abstraction and set shifting, measured by WCST solely to the prefrontal cortex broader neurocycle. Instead of viewing the WCST as a solid true frontal test, they emphasize a more comprehensive understanding from the context of the Halstead written battery, which they are. What does battery mean? In psychology. In psychology, a test battery is a set of several, often different assessments administered together to provide comprehensive evaluation of an individual's cognitive, emotional, or behavioral functioning. These batteries help clinicians make diagnoses, track progress, or determine the need for support covering areas like memory, intelligence, or personality. Okay, so there's different assessments. That's what a battery is. Interesting. Okay. So Halstead and Rayton said that they have a better way of looking at cognitive disabilities in a comprehensive way. Critique of performance interpretation. The review contributed to a broader debate in the 90s alongside researchers like Badley, Della Sala, and Tranell about the validity of using executive function tests to pinpoint localized brain damage. Right, so what are they saying exactly? That my test is better than yours? Presumptions about the functions of the frontal lobes and the sensitivity of certain tests to measure frontal lobe functions are having a substantial influence on both clinical and research conclusions. In this paper, the authors examine the details of the studies that have contributed to the presumptions and find that the evidence to support these conclusions is weak. A detailed evaluation of the evidence relating to the Wisconsin car sorting test and Thurston word fluency test is also presented. Finally, the development of the belief that frontal lobe function can be specifically measured is reviewed. The authors of this paper conclude that the bewildering array of deficits attributed to frontal lesions still seem to prevail. Okay, so I see where they're coming from. They're saying that it's not just looking at one area, it's a holistic situation. Okay, to be fair, reading all these papers is important, especially for research purposes. You have to hear the other person out. Okay. Excuse me. Wisconsin card sorting test performance in patients with focal, frontal, and posterior brain damage. Effects of lesion location and test structure on separable cognitive processes. 46 patients with single focal lesions, 35 frontal, 11 non-frontal, were administered with Wisconsin card sorting test under three conditions of test administration. The three conditions varied in the amount of external support provided by a specificity of instructions. The WCST, while a multifactorial test, is specifically sensitive to the effects of frontal lobe damage if deficits in language comprehension and visual spatial search are controlled. Mm. There's also specificity of functioning within the frontal lobes. Patients with inferior medial frontal lesions, unilateral or bilateral, were not impaired on the standard measures, although they had increased loss of set when informed of the sorting categories. Patients with inferior medial frontal. Let's search this. Okay, now. So justice for the Instagram. Inferior medial region primarily corresponds to the gyrus rectus, straight gyrus, and the medial orbital gyrus on the ventral surface of the frontal lobe, located within the orbital frontal cortex. This area is crucial for social behavior, emotional regulation, decision making, and olfactory processing. It sits adjacent to the longitudinal fissure just above the olfactory bulb. Okay, inferior medial frontal typically refers to the gyrus rectus or the medial orbital gyrus located in the undersurface ventral aspect of the frontal. Anatomical breakdown: inferior surface, the part of the frontal lobe resting on the floor of the skull, orbital cavity. Medial portion, the area closest to the brain's midline. Key structure: gyrus rectus, long, narrow, straight gyrus located most medially on the inferior surface. Okay, this region is part of the orbital frontal cortex and the broader medial frontal cortex, MPFC, primarily involved in decision making and valuation, like the dorsolateral prefrontal cortex, determining the subjective value of rewards and making choices based on expected outcomes. Emotional regulation, controlling emotional responses and social cognition, including empathy and theory of mind. inhibitory control, suppressing impulsive actions or irrelevant thoughts. Okay. So they're stating here that there's also specificity of functioning within frontal lobes. Patients with inferior medial lesions, unilateral, bilateral, were not impaired on the standard measures, although they had increased loss set when informed of sorting categories. Verbal instructions may provide a probe to improve diagnosis and prognosis, assessment of the potential efficacy of treatment, and the time frame of plasticity of specific cognitive operations. The likely cause of a medical condition. Opinion based on medical experience in life. Okay, interesting. Further evidence of PFC involvement in task switching comes from tasks related to WCST. This is key as well, actually. That's Robert Robbins Owen, including tasks for switching the primary children other terms. Is this Neil Burgess and Tim Chalice? Could be. Let's check. Because Neil Burgess, I am familiar with him. Okay, where is my H1? It's not this. Seriously, this is annoying sometimes. Don't need this. Don't need that. Don't need that. Don't need that. Don't need that. What's this? Don't need that. Okay, so where are we? Paul Burgess. I think he killed himself, no? No, it's still around. Which neuroscientist killed himself? Okay, let's see. Yeah, John Driver. A sad life. Pathetic, quite frankly. Anyway, okay, so cognitive and neuroanatomical correlates of multitasking. Abstract. Patients who show strategy application disorder can show deficits restricted to situations requiring multitasking, but the precise neuroanatomical and cognitive correlates of this problem have been rarely investigated. In this study, 60 people with circumscribed cerebral lesions and 60 age and IQ matched controls were given multitasking procedure which allowed consideration of the relative contributions of task learning and remembering, planning, plan following, and remembering one's action to multitasking performance. Lesions to the left posterior cingulate and forceps major regions gave deficits in all measures except planning. So planning was not affected. Hmm. Right. Remembering task contingencies after a delay was also affected by lesions in the region of the left anterior cingulate. And rule breaking and failures of task switching were additionally found in people with lesions affecting broader areas 8, 9, and especially 10. Planning deficits were associated with lesions to the right dorsal prefrontal cortex. Right dorsal. Ah, so planning was affected. Interesting. Theory of the relation between cognitive constructs underpinning multitasking was tested using structural equation modeling. The results suggest that the three primary constructs that support multitasking retrospective memory, prospective memory, and planning, with the second two drawing upon the products of the first. What was prospective memory? What was that? Future time. This is probably past. Sorry, semantic. And the second, it is tentatively suggested that the left anterior and posterior cingulates together play some part in retrospective memory demands, while prospective memory and planning components make demands on processes supported by the left areas and the right dorsolateral prefrontal cortex. I think Reddish speaks about this as well, if I'm not mistaken. 231. Okay, right. So going back to O'Reilly's paper here. Why? Despite the evidence for the involvement of PFC, the precise mechanistic role of this brain area in task switching remains unclear. In this paper, we present biologically based model performing efficiently like task switching does help to eliminate the mechanistic role PFC plays. Specifically, our model is founded on the idea that PFC is specialized for activation based work. Okay, so yeah. Brave Cohen. By representing information as maintained activation states. By representing information as maintained activation states, the PFC can contribute to task switching by rapidly updating these activation states in response to feedback. By representing information as maintained activation states, the PFC can contribute to task switching by rapidly updating these activation states in response to feedback. This activation switching can be much faster than the structural changes. Okay, so what's being stated is that by representing information as maintained activation states, PFC can contribute to task switching by rapidly updating these activation states in response to feedback. So maintain activation state and then PFC contributing to task switching by rapidly updating these activation states in response to feedback. This activation switching can be much faster than the structural changes that underlie adaptation of connection strengths between neurons. So it's essentially looking at activation states and the weight of a neuron, as as explained by connectionism. Connectionism is the idea that a representation is weighted by a neuron. You have the input layer, hidden layer, output layer. I've mentioned this many times. So this rapid updating in the prefrontal cortex can be specifically triggered by a dynamic gating mechanism. Controls updating the activation based working memories maintained in the PFC. Okay. So PFC rapidly updates still don't understand by representing information as being states representing information as being by representing information as obtained activation sites, states, Allahu Akbar, states, losing focus here. I think I need an T. Can contribute. أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Contribute to task switching. Okay, task switching by rapidly updating these activation states. Okay, these activation states in response to feedback. In response to feedback. This activation switching can be much faster than the structural changes that underlie adaptation of connection strength. Okay, so the claim is that these rapid activations in response to feedback, this is faster than structural changes, structural changes that underlie structural changes that underlie adaptation adaptation of connection strength between neurons. Standard neural network mechanism. Okay, so what's a standard neural network mechanism? Someone might be wondering. It's your classic connectionist model. I'll show you from a book in a second as well. Where is it gone? Which looks like this. Classic model. This is more accurate. This is just a theoretical idea or neural network model, and AI agents use this exact foundation here. You have convolutional network models as well. Convolutional. So convolutional neural network. It's a bit different, a bit more advanced. This is what it is. You have the representation input here. Go through convolution plus ReLU is, I think, relearning unit. I forgot actually. I could check. Rectify linear unit, commonly used activation function in deep learning networks. Activation determines whether neuron should fire or not based on the output. So the pooling of all of this data, a map is formed and then it's layered. And then you have, again, these blue circles, they are demonstrating the neural network that I was speaking of. And then the output, you have red panda, animal on the tree, waving his arm, and all these other stuff. So probabilistic distribution. What's most likely? What is this picture most likely representing in its easiest terms? right? So it's something that I will be speaking about at some point. But yeah, this is it's more complicated because now you're looking into not only computational neuroscience, we're looking into deep learning, various models within deep learning. So yes. Right, so this rapid updating can be triggered by dynamic gating. So this is triggered by dynamic gating. Okay, so this will be described by the authors a bit later down in the paper. Made some notes on it as well, which we will touch upon. That controls, so this controls the updating, okay, of activation based working memories maintained in the PFC, maintained in the PFC. Present model goes beyond earlier models of task switching involving dynamically gated prefrontal cortex system. They've already stated that, it's just reiterating in a bit more detail. By developing prefrontal cortex and other representations entirely from experience-driven learning mechanisms. So that's when during task switching and doing the task itself, the participants are supervised. Right, so all the experiences learnt that is being picked up in the form of representations, operating in the context of repeatedly switching among a set of tasks. What the task is, what they're switching around, is going to be explained in a moment. Our previous models of prefrontal, sorry, one second. Our previous, where is it gone? Our previous models of PFC function have used hand-coded PFC representations. So this represents an important advance that opens up many new avenues of research into the nature of prefrontal cortex representation as a function of task demands. As this was written more than 20 years ago, let's see what Gemini has to say about this. So what I'm going to do is click this, go here, and just do question mode or AI mode here. Prefrontal cortex representations are highly flexible and adapt their nature, including their dimensionality, selectivity, and temporal stability to match specific task demands rather than maintaining static sensory memories. The prefrontal cortex dynamically configures its neural states to prioritize task relevant information and guide cognitive control. So, in a sense, it's consolidating the current task at hand. So, it fits what the authors were saying initially. If you go here, looking at temporal differences and reward prediction learning mechanisms. How would you know the differences, the temporal differences, and how would you know the outcomes of reward prediction learning. Very simply, the model has to operate within a time frame, of course, standard, but reward prediction is a bit more challenging. So with this, you have to have the model work and exercise its muscle, its thinking muscle. Of course, this is all theoretical and this is a model. This is not an actual human brain, but it's mimicking features of executive function and the errors that come with executive functionalities. Nevertheless, we build upon earlier work by employing a similar dynamic gating mechanism based on reward prediction learning mechanisms. We begin with a summary of the task switching task, followed by a description of the model. This is key, what the authors are stating. We present results from both the dynamically gated PFC model and a number of comparison models that systematically explore the overall contribution of the PFC in the model and the effects of various mechanisms that influence the dynamic gating processes. So first and foremost, they're putting forward their own model, comparing it to previous models, and then systematically, as in they will break down, I'm guessing maybe task by task, maybe function by function, or process by process. I don't know yet. They will do this systematically, both the overall contribution of the prefrontal cortex in both so of course this is centered around the prefrontal cortex, so they're looking around the overall contribution of the prefrontal cortex in their model and previous models and the effects of various mechanisms that influence the dynamic gating process. What is that? Be explained by the authors, of course. We conclude with a discussion of the implications of having a dynamic gating model that can develop useful internal representations. Okay, nice and simple so far. Dynamic, the dynamic naming tasks. By the way, those on TikTok, YouTube, and Instagram Live, thank you very much. If you can just like and follow, and if you have any questions concerning neuroscience, feel free to do so. No problem at all. Right, so the dynamic naming task. The task we use for testing the model is a modified version of the widely studied Wisconsin card sorting tasks, okay, where inputs are cards having feature values along different stimulus. Okay, so this is the core idea of the WCST task. So different dimensions, color, shape, number, or some say color, form, number. And the essence of the task is to focus on one of these dimensions for a series of trials and then switch to a different dimension. Okay, very straightforward, nice and easy so far. In our version, the output involves naming a feature instead of sorting cards into piles. Thus, we refer to this as the dynamic naming task. Specifically, each stimulus item has 5 feature dimensions with 3 possible feature levels in each of the dimensions. The goal of the task is to guess an unspoken target dimension and report the feature value along that dimension for each item. So figure 1. So the goal of the task is to guess an unspoken target dimension and report feature value along the dimension for each item. So it's explained here the task. Each stimulus has 3 features: shape, color, size, with 3 possible feature levels: circle, square, or triangle. That's level 1. So these are 3 levels of the shape: red, green, blue. 3 levels of the color: small, medium, large in terms of the text, the size, right? And so, and hidden dimension is the size of the presented sample stimulus. Hidden dimension. Okay, interesting. In the first two trials, the subject chose the sample matching level in the wrong dimension and consequently got negative feedback. In the last trial, the correct dimension and feature value selected, leading to positive feedback. So I think this is where the maybe the dopamine reward situation comes from. Schulz, Stangelski, Kuhan. Yeah. Hmm. Control. Let's check this one out very quickly. Okay. Tell me this exists. Should exist. Open access free. Okay. What's that? 703. Okay. Simple, straightforward. John Driver. Oh my God, we were just reading about him, how he unalived himself. That's mad. Right, so let's open this up. No problem. We have 713. Why is this not coming up? There we go. Okay, so this is the paper. It's been spoken of. Hmm. So they seem to take their models from here. So let's just clear this for a second. This is really interesting. Right, so let's very quickly read the abstract for this because this is related to the gated mechanism. I'm just going to touch on that and then might just proceed with this paper myself because it's a lengthy paper, and I just love sharing these things with everyone, and people can benefit from this. So the control on the control, the role of dopamine regulating prefrontal function and working memory. Todd Braver and John Cohen, every single Stein. Abstract. So an important aspect of cognitive control is the ability to appropriately select, update, and maintain contextual information related to behavioral goals and to use this information to coordinate processing over extended periods. In our novel, neurobiologically based connectionist computational model, the selection, updating, maintenance of context occur through interactions between PFC and dopamine neurotransmitter system. Phasic DA activity, so that's dopamine activity, serves two simultaneous and synergistic functions. Number one, a gating function, which regulates access of information to active memory mechanisms observed by PFC. So this is what he is talking about here. I'll go braver here. Yeah, a dynamic gating mechanism in the model is based on the idea that working memory updating can be driven by changes in reward prediction. So this is the paper, right? And I will try and make a note of something. I can just do this, that. So if you, this is what chapter 31. Chapter, why is it so difficult? Why is chapter 31? Chapter 31. Yeah, okay. O'Reilly as formalized in the temporal differences reinforcement learning mechanism. This is important as well to look at reinforcement learning mechanisms. Formalized in the temporal difference learning mechanism. Yeah, I haven't really looked into reinforcement. I know Sutton has done a lot of work in reinforcement learning, and obviously it's influenced AI and cognitive science and neuroscience, but inshallah at some point we will. The TD, temporal difference algorithm, employs an adaptive control. Is it adaptive control? Adaptive critic that attempts to predict future rewards, and it drives learning as a function of differences in these predicted rewards. The functional properties of adaptive critic provide a good, if imperfect, fit to the firing properties of midbrain dopamine neurons in the VTA. The TD algorithm employs an adaptive critic that attempts to predict future rewards, and it drives learning as a function of differences in these predicted rewards. Okay, relevant. Okay. The functional properties of the adaptive critic provide a good, if imperfect, fit to firing properties of midbrain VTA area. Okay, that's the interesting claim. It has been shown that the VTA ventral segmental area fires dopamine bursts for stimuli that are predictive of reward. I think I have seen this in again Reddish's book. Let me check this out. Schultz 93, right? I think I have seen this. No, but the same author has written other stuff. Schultz predictive reward signal dopamine, Schultz 97, Schultz neuronal coding of prediction. Anyways, yeah, these are key texts. Schultz, I think it's mentioned in the chapters I was reading. Very quickly, just double check here. Okay. Yeah, so Schultz, I am familiar with Schultz's work in dopamine research. Fascinating stuff. In a way that is generally consistent with adaptive critic mechanism. Okay. If rewards are expected but not delivered due to behavior error, dopamine neurons exhibit reduced firing corresponding negative error signal. Come on, buzz. Task relevant information should be maintained. So, task relevant information that should be maintained is a reliable predictor of reward and should thus elicit dopamine firing, resulting in the updating of working memory. Task relevant information that should be maintained is a reliable predictor of reward. Yeah, of course, because it's within the same context. That's being driven towards a goal. Okay, yeah, that's fine. And it should thus elicit dopamine firing, resulting in the updating of working memory. Let's just use Cohen's paper at the moment. And the negative error signal should reset working memory representations. Okay, let's underline that. The net effect is to produce a form of trial and error search by activating and deactivating PFC representations. The net effect. Right. So again, he's referencing himself twice. He's done that before. So he referenced himself and Munakata and himself from 2002. I saw Munakata somewhere here. Here. Previous models. Okay, I think this is relevant, of course. Okay. In the context of dynamic naming tasks, the adaptive critic unit learns to expect reward when the network is performing correctly, which stabilizes prefrontal cortex representations, and these expectations are disconfirmed when the task is switched and the network starts performing incorrectly. Disconfirmed, which destabilizes the prefrontal core representations and allows new patterns to be activated. In essence, a new task context. Okay, so in the context of dynamic naming tasks, so it's where you have to small, medium, large, identify that. The adaptive critic unit supposedly learns to expect reward when the network is performing correctly, which stabilizes the PSU representation, and these expectations are disconfirmed when the task is switched and the network starts performing incorrectly, which stabilizes the PFC representations and allows a new pattern to be activated, i.e., a new context, new task context. This stabilization and destabilization of prefrontal cortex representations facilitates task switching. This stabilization and destabilization. Okay. We implemented PFC active maintenance using a combination of recurrent excitatory connections and intracellular ionic conductances that provide persistent excitatory input to units that are active when the gating signal goes positive, enabling them to persist over time. Frank, okay, let's see what Mr. Frank has to say. Mr. Frank. Okay, that's a journal. Hmm. It's an interesting paper. Learning from random gain does not transfer into picked up a similar. So here he's quoted Dehaney, which we've been looking at. What's a Zipser doing here? He's a researcher in hippocampal stuff. I bet you there's going to be a hippocampal discussion in this paper. I have a feeling. Let's check out. No. And Torino, maybe? No. Maybe he's called something here. Like identification mark. No, I'm sure. Right, let's go through this. Okay, so phasic dopamine activity, I think that's what it is, right? What was it? DA, dopamine activity. A rapid transient burst of dopamine released from neuron in response to some sustained tonic. Let me check something here because I have another book here, which is the psychobiology of personality. This also talks about dopamine and the neuroscience of dopamine, looking at personality. Yeah, I've been studying this book for some years now. I understand it fairly recently compared to before, but let me just see. Medial mobility, oxon, works, okay, dopamine 161. 161. Okay, yeah, this one. No, that's not relevant. 176. What's this? Illustration of non nor adrenergics and dopamine caffeine precursor. Dihydroxyphenethylene. Dope as a precursor or transmitter DA and NE. Enzymes monoamine oxidase catechol transferase COMT are involved in degradation of mm, 3 3 methoxy 4 hydroxyphenyl glycol MHPG and phenyl acid are metabolites in the breakdown of exactly right. Cancer, general inhibition. More sexual behavior. Okay. nine 19 215 215. No, none of this is relevant. 215, 215, 215. Yeah, no, none of this is relevant. But it's interesting. Personality studies also contribute. So, anyway, phasic dopamine activity serves two simultaneous synergistic functions: a gating function, which regulates access of information to information to active memory mechanisms subserved by the prefrontal cortex, and a learning, and number two, a learning function, which allows the system to discover what information is relevant for selection as context. We present a simulation that establishes the computational viability of these postulated neurobiological mechanisms for subserving control function. Okay. Okay. Yeah, I need to read this. So let's just touch base back on it. Computation of reward. Computation of reward plays a adaptive gradient. Computation of reward plays a critical role in a model because it drives the AC unit behavior. The most straightforward solution would be to send the reward signal directly to the computation. Computation of reward it drives the AC unit behavior. The most straightforward solution would be to send reward signal directly to the AC unit, but this solution would cause instability within a network because of intra-task errors. That is, the model and actual subjects always have a low level of background errors in task performance due to small weight changes interacting with interactive activation dynamics. Consider the case where the model produces an intra-task error with a direct reward signal. The error causes the AC unit to immediately destabilize the prefrontal cortex representation, leading to a search among other possible subtasks, switching back to the subtask the model was just in. Consider the case where the model produces an intra-task. Which among We adopt a fault-tolerant solution by averaging the reward across a period of n steps and setting a threshold on this average of positive versus negative rewards, i.e., if the average reward is above threshold, a positive reward is given, otherwise a negative reward is given. Thus, if isolated errors are produced, the average remains high, and the AC unit nonetheless gets positive or signal does not induce context switching. With the consistent errors associated with task switching, the average will go below threshold and a negative reward will be given. Now, however, that this has a drawback in that the model has to produce more errors before being able to switch context, degrading overall performance. The choice of n is then a compromise between stability and performance. We use the value of 2. Okay. Now further optimization can be made. Consider when the model is switched to new context. This switch occurred because the model produced wrong answers and because we average the reward over time. We carry forward errors from the past when switching to a new context. The switch occurred because the model produced wrong answers. The switch occurred because the model produced time we carry forward errors. Yeah, okay, I understand that. These errors will incorrectly penalize new content which should be tested before deciding on. Actual errors. These additional assumptions are important for the model's behavior and thus stand as a test of prediction. Okay. Well, inshallah, tomorrow we'll go into more detail of this. No, it's time. Astaghfirullah. Time of Qiyamul Layl. Inshallah, it's the 5th day of Ramadan. Tomorrow it's the 6th. Well, the 6th has begun in a sense. Assalamu alaikum wa rahmatullahi wa barakatuh.